Welcome back. So parts 1 and 2 of this linear programming lesson was recorded in my class in the spring semester of 2024, and I realized that it cut off early on that last video, as you guys just probably noticed, and so now I am finishing it here on October 2nd, 2025, so that you guys on Friday, October 3rd, can watch this in class or anybody else in the future. So anyway, what I had just talked about was that we need to know where these two lines cross, and I didn't graph it extremely accurately to know for sure. If you can look on your graph and know for sure where those two lines are crossing, you could name that point here. However, if we can't tell for sure, we have to figure out another way to know where these two lines cross. How do I figure out where two lines cross if I know their equations? I think we already know how to do this. If one of them is 3x plus 6y equals 180, I'm forgetting about the inequality. I'm just putting an equal sign there because I just want to know the one point where these two lines cross. And so I could just use substitution or elimination to do this. Probably elimination, right? So I'm going to multiply the top one by -4. Make it negative 12x minus 24y equals negative 720. And the bottom one by 3. Make it 12x plus 15y equals 540. And my pen is already dying. We'll go to the pencil now. Add these two equations together. And this is negative 9y equals negative 180. And so now I divide by negative 9, get y equals 20. If I plug 20 in for y on one of these, I'll put it right here. 6 times 20 is 120. Subtract it over, that's 60 divided by 3. Looks like x is 20. So if you could tell, I mean, mine's pretty accurate, to be honest now. It does look like it crosses at 2020, so if that's what you guessed from your graph, you were correct. But now we know 100% that it's 2020 because we proved it with the algebra. So now I will continue this. Okay, 0, 30. I would plug 30 in for the y there. Okay, so that would be 12 times 30. That's $360 if they produce 30 of animal 2. If they produce only animal 1, 45 times 8 is also 360. But if they do 20 of each, that'd be 8 times 20, 160, plus 12 times 20, 240. Add those together, and it's $400. So we have just found that what they should do to maximize profit is produce, and I'm going to write the answer right here, 20 of animal 1 and 20 of animal 2 for a profit of $400. And that is the linear programming process. So what you're going to get now is that you are going to get a worksheet. Okay, this worksheet has two problems. On the front, we're going to talk about model cars and trucks. And as you can see, I've kind of started this one for you. Okay, telling you to use X to represent cars. I gave you one of the inequalities. I want you to come up with two others, but I will tell you that those two others do not include the x is greater than 0 and y is greater than 0. Okay, so you should be able to come up with two in addition to that once you read through the story. So you'll read the story, put your other two inequalities, graph all of them, see where your vertices are, and plug it into your maximizing equation, which you'll be able to know because they tell you the profit for cars and the profit for trucks. So I'm not going to explain too much right now because you'll just need to read the problem yourself. I'll just tell you the back is another problem where I don't give you as much, but it is talking about battery and wind-up operated watches. All right, so go ahead, give those a try. All right, and that's all I have for you. Have fun. Bye-bye.